Hello Anu.
Hi,
Hi Anu, how are you?
I'm good, thank you. How are you?
I'm fine, thanks. Okay,
Okay.
okay, so we were doing something based on transformation, right? Okay, Anusri?
Yeah.
Yeah, so we understood two kind of transformations where the figure remains congruent in translation, reflection and rotation, and also we've done enlargement or diminished, that is dilation. So,
Yeah.
okay, so tell if you have any doubt in those topics that we discussed.
Um, for dilation, like for enlargement,
Mm-hmm.
if you were given a fraction to
Yeah,
enlarge,
yeah.
how would you do it?
See, the fraction, there are two types of fractions, proper fractions and improper fractions. And if you remember,
Okay.
that's called a scale factor, right? The
Yeah.
factor they give us, that's called a scale factor. So if the scale factor is greater than 1, or I can more precisely, I can tell that absolute value of a scale factor is greater than 1, the figure is only always enlarged. Now, how it's greater than 1? Or let me tell you first. Proper fraction is something like 3 over 5. It's a proper fraction, right? 7 over 9. It's still a proper fraction. So proper fractions are always less than 1. If the proper fraction is always less than 1. So whenever we are given a proper fraction, the figure, okay, so a scale factor whenever is less than 1, the figure is diminished, right? It's not enlarged, it's
Yeah.
basically becomes smaller. It's called
Yeah.
diminished, I think. This is the spelling, yeah. And whenever the scale factor is greater than 1, that's called enlargement. So when it's possible,
Okay.
we can still have a fraction like 9 over 7, 8 over 5. These are the improper fractions. So improper fractions
Yeah.
are always greater than 1. So whenever you have that improper fraction, there will be an enlargement. Whenever there is a proper fraction, there will be a reduction. The size will be decreased. Just like say you are given a triangle in the coordinate plane and you are given the scale factor to be 2/3. Now what do you think? Whether 2/3 is a proper or improper fraction?
It's a proper fraction.
It's a proper fraction. So whenever there is a proper fraction, it's less than 1 means it's going to be
Yeah.
decreased. The size is going to be decreased. But at the same time,
Okay.
suppose a scale factor is given to us as 7 over 3. It's an improper
Mm.
fraction. So as I told, improper fraction is always greater than 1. So if it's greater than 1, there
Yeah.
will be an enlargement. Now, I use
Okay.
this absolute value symbol. Why? Because it might possible that we can have even a negative scale factor. We have a chapter
Okay.
after that when we are given a negative scale factor. So whenever the
Mm.
scale factor is negative, the figure is formed at the opposite side. Like, let me tell you what happens. Say we are given an example. There is a triangle, or I can also draw the coordinate axis before that. Suppose there is a triangle like this. This is our triangle, and it's going to be enlarged, or let's say
Okay.
it's somewhere here. Okay. So if it's going to be enlarged, what you exactly do, you have to join it first of all. Oh, sorry. You join. Suppose the scale factor is given to us as 2. The scale factor is 2. It simply means it's going to be increased. Its size is going to be increased. So how do you increase the size? You just and say the center of dilation is the origin this time. So if this is origin, and okay, let me just draw it little above. So now this point will be twice. We just have to get a distance which is twice. So say this is, we get this point.
Okay.
Yeah. So this point is basically transformed to this. Now I get another point. Similarly, let's say this was a point. Mm, say this is the point. So now it was 1, 2, like 3, and then it's 4. So I can just make it twice. So it's 1, 2, 3, then 1, 2, 3, and it's 1, 2, 3. So it goes somewhere here, like this. We get the another point over here. I can just draw it. And one more point is there, which is this one. So it's 1, 2, 3, 4, 5. So it's obviously twice of that. So it will be transformed 1, 2, 3, 4, 5. Okay.
Okay.
Yeah. So right now the figure we've got is this one. This is the diagram, right? It's a dilated one. Earlier we had this one, a smaller one, a smaller triangle, as you can see. It's not visible properly.
Hmm.
Let me just again highlight that. Mm, this one. This one was the original
Okay.
one, and now it has been dilated by the scale factor of 2. But now at the
Hmm.
same time, suppose a scale factor was negative 2. Now what would have happened? So I just
Would it
again,
go?
uh we have to just draw
Would
it
it get? Yeah.
in the opposite side. It will still be enlarged because the absolute value is still equal to, see, it's negative 2, no matter if we talk about absolute value of a scale factor, that is negative 2,
Yeah.
that is, it's still greater than 1. It's 2 is greater than 1, right?
Hmm. Yeah.
It's still an enlargement, but since it's negative 2
Hmm.
this time, so let's say this is our figure given to us. So if this is the distance, say this is our 2 units distance. So now the figure will be considered in the opposite direction. The image will be in the opposite direction at a twice distance over here. Okay.
Hmm.
Similarly, say this was our, this is the 1, 2, 1, 2, 3, 4, 5, 6, and so in the same manner it goes in the opposite direction from that point. So
Okay.
the distance we have to consider, it's not from there, we just have to consider it was 6. So 1, 2, 3, 3, 6, then 3, 3, 6, and 1, 2, 3, 4. Yeah, it goes somewhere here. It goes in the same direction, like in the same line, but in the opposite direction. It goes somewhere here. And now
Okay.
the other point, let's also mark this one. This one is over here. Let's say this point. So it's at a distance of, let's say it's 1, 2, 3, 4 blocks. 4 blocks diagonally. So in the same manner, it goes 8 blocks diagonally. 3, 4, 5, 6, 7, 8. It goes somewhere here. So it's
Okay.
dilated over here. So due to that negative sign, it has gone into the opposite direction. And as you know,
Okay.
yes, this is how it looked like. Earlier it was over here. Now it has come over here. So that's how it exactly happens. So if the scale factor is positive, the figure is transformed in the same side of the given figure. But if the scale factor is negative, it goes in the opposite side of the figure.
Okay.
And obviously, your question was about a fraction. So remember, if it's a
Yeah.
proper fraction, it becomes diminished. If it's an improper fraction, it gets enlarged because improper fraction is greater than 1. Okay,
Okay.
do you still have any doubt regarding that?
No.
Okay, Anu. So after that, on which exercise we were, do you remember?
Let me check.
Okay.
I think we were on exercise 7.4S.
Yeah, there are some questions based on dilation. So see if you have any question difficult for you.
Hmm, how would you do C?
C of what?
Six. C.
6C. Okay.
Yeah.
It says enlarge triangle D by a scale factor of. We can't actually enlarge, though they have given a word enlargement, but it's not going to be enlarged. It will be diminished. Its size will be decreased. So enlarge the triangle D
Okay.
by a scale factor of this with respect to the center. Center, that is 0, comma 0. Okay, no problem. I can just open the graph sheet and we can then try to enlarge that. But where is the triangle D? Um, I think before doing this question, we must solve the first question. Then only we'll be able to understand where is the triangle D.
Yeah, could be.
hmm So, shall we start from the 6A part?
Yeah, okay.
Yeah, because unless we solve the first part, we won't be able to know where exactly it lies. So that's why we need
Okay.
to first start with the first question, and then after we can continue with the others. Okay, so this is our coordinate plane. This is the y-axis. This is the x-axis. And now Anu, it says draw an x-axis from -13 to 5 and a y-axis from -7 to 3. That is -13 to 5. They might ask us to just highlight that distance on that. From -13 to +5. That is 1, 2, 3, 4, 5. I'm just going to mark it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. So you see it's +5. That's here. Here we've got +5. And this point is basically -13. That's what question has said. And oh, it has said on x-axis. Sorry. It's not on the y-axis. It's said on the x-axis. You have to assume -13 to +5. Okay, let me just draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. From here to 1, 2, 3, 4, 5 up to this. So as you see, this is our, I just have counted. This is -13 and this is
Okay.
+5. It also said to draw y-axis from -7 to +3. So okay, 1, 2, 3, 4, 5, 6, 7. -7 to +3. You can also mark. This is my -7. Now what it says, draw a triangle D with vertices -1, 1 and 2, 2, 4, 0. So -1, 1 will be somewhere here, and then but I think it will be difficult. Uh, no problem. I'm just going to draw it. It's figure. If we just
Okay.
have half of that, that will be very difficult to plot. But it's okay. -1, 1, 2, 2, 2, 2 is somewhere here, and 4,
Mm-hmm.
0. 4, 0 is lying at the x-axis only. Now that will be your triangle D. Okay.
Okay.
No problem. So I can first join all of the sides like this. This is our triangle. Oh, sorry. This has to be a triangle. So that's how we draw it. And now the question says to enlarge it. In the B part, it says enlarge it by the scale factor of -3 with respect to origin. So it's okay. It's 3 times. And since it's enlargement with respect to origin, so if you remember, I told you a rule. If the dilation going to be performed with respect to origin, you can directly multiply its uh, coordinates by the scale factor. That's the one way.
Okay.
The other way, we have the as usual method that we have to just join the sides and then we have to enlarge or just go in the same direction or in the opposite direction by the given scale factor. So let's say this is 1 unit,
Okay.
right? 1 unit. So scale factor is
Yeah.
-3. So now we need to go 3 units in the opposite side. So
Mhm.
we now go 3 units in the opposite side like this in the same line. So that's our point. That's one of the point. I'll also cross-check using the method that I told by simply multiplying the scale factor to the coordinates. But first do it in this
Okay.
way. Even we can consider we join this point. It's 2 units. So in the opposite direction again we need to go and it's 2 units, so 2 to the 4 to the 6. It's this much. 2 like 4 units in the diagonal. See there were 2 units,
Okay.
so that's why we just go 6 units because the scale factor is -3. Due to that
Mhm.
negative sign, we are going to opposite direction, not in the same direction. And this is over here.
Okay.
So, okay, let me also mark. This is the distance 4 units. So 4 threes are 12, but in the opposite direction. So it was
Mhm.
-13, so it's -12 up to this. And as we have reached to this point, we can then just join all of them. Okay, so that's a dilated one, right? The scale factor was
Yeah.
-3, and since the dilation is being performed with respect to origin, so let me tell you now. I could have even directly used that method. It was -1, 1, it's 2, 2, it's 4, 0. So if you remember, I told you a method. The dilated one, let's say it's A dash. That point was suppose A, so this was A dash. This was B, it was B dash. It was C, so it was C dash. So A dash is what?
Okay.
A dash has the coordinates. Mm, say A dash has x comma y. So it will be basically what? Scale factor times x coordinate of A and scale factor times y coordinate of A. Like it's
Mhm.
multiplied. So even as you see, it's -1, 1. So as you multiply -3, it becomes +3, 3. +3,
Yeah.
-3. And yeah, look at this. It's nothing but the same. +3, -3. Even if you multiply 2, 2 by -3, it becomes -6, -6. And yes, it is. As you count, it will be the same thing. Similarly, if you
Okay.
multiply 4, 0 by -3, so it's -12, 0. So everything is clear now, right? If the dilation is performed with respect to origin, you can even use direct multiplication of the scale factor in order to get the coordinates of the dilated image. Now, Anu, they asked to enlarge the triangle D by a scale factor of -half. So I think this time it's
Okay.
very difficult because we can do actually. Okay, let me just try in this. In this figure, it will be difficult. I can open the next one, the other grid. -1, 1, 2, 2, and then we had 4, 0.
Yeah.
So this time I just have enlarged it a little bit so that we can drop it properly. And this time the scale
Okay.
factor is negative half. Means we can even directly multiply negative half to each of the coordinate. It was -1, 1, 2, 2, and 4, 0. So now -1, 1 is what? It will be see, scale factor was this time it's negative half. So -1 times negative half you have to multiply. 1 minute, let me
Yeah.
write. It was -1, 1. So you multiply negative half to each of the term.
Mhm.
So we get positive half, common negative half. So it's zero point 0.5, -0.5. So it will be somewhere here. It's positive half goes over here and negative half goes over here. So we get a point somewhere here, right?
Okay.
Similarly, 2, 2 get multiplied by half, negative half. So we get -1, -1. So -1 will be -1, -1 will be somewhere here. And 4 is also get multiplied. So it's -2, 0. So -2, 0 will be somewhere here. Now we just join all
Okay.
of them. So that will be our dilated. It won't be enlarged, or you can say it's opposite, it's enlarged negatively, or that is just diminished, you can say, because the scale factor
Okay.
was less than, it was a proper absolute value of our scale factor was less than 1. That's why it got decreased.
Okay.
Yeah, so the one way was this. Other way you could have done is the same that we used to consider the distance. We first join this side and then it's half the distance. So half the distance is obviously this much that we have got over here our point. Similarly, this distance, look at this distance, it's 2 units. So we just go 1 unit
Yeah.
opposite because it's negative, because it's half.
Mhm.
Similarly, you could have considered this point, so this is half of that in the opposite direction, so it's again 2. So everything is clear
Okay.
this time. Yeah.
Yeah.
Okay, Anu, so you can tell the next question that you have that you find difficult for you.
I think I'm fine on exercise 7.4S.
Okay, so you can just come to exercise 7.4a, and the
Mhm.
similar questions are there. We just have to perform dilation by the given scale factor.
Okay.
Okay, so let's see the questions. I think the first question is saying copy each diagram on a square grid, and then shape A have been enlarged onto shape B. Then find the center of enlargement and calculate their scale factor. So let me do one thing. I'll just try to upload the figure on the board, which are there in the first
Okay.
question, and then we may try about them. Just 1 minute. I need to log in from my phone, in fact. Just 1 minute. I'm logging in from my phone.
Okay.
It's connecting. Yeah, it's connected now. Okay, I'll upload an image now.
Okay.
We'll begin with the first one first of all. It's uploading.
Okay.
Yeah, that's a diagram. Can you see the image on the board?
Yeah.
Okay. So this time, let's see, we have been given this figure only and we have been asked to find the center of enlargement and the scale factor as well. So scale factor can be
Mhm.
determined easily, that you see the side are just twice, seem to be twice. So scale factor is just 2 because it's supposed to,
Yeah.
so it's 1, so it's half. This is 2, so it's 4. So scale factor is just 2. Now, how to get the scale that center of enlargement? For that, let me see. I think it can
Isn't it somewhere over there? Like
here somewhere,
somewhere over here.
right here.
I think because like you can draw a line over here and like a line
Can
over
you
there,
can you
and
can
we
you
can
just enable
put.
your pen tool? I can't see where are you pointing out.
Okay,
Just
so if you were to do it here,
yeah, I think so.
then that'll work because that will happen like that.
hmm
Wait,
Yeah,
something like that.
yeah, I
Yeah,
think
like
so.
the line can go like that.
Okay, yeah, it can be drawn, but I think it should have. Oh, 1 minute. It should have been in the same line, right? But right now, I
Yeah.
know if you notice, if we just draw a line, it isn't coming in the same line.
Hmm.
So it should have come in the same line, in fact.
Yeah.
So what? Let's now do one thing. It's better to have our just draw a line. Let's try to draw a line
Okay.
in such a way that they simply go in the same direction. 1 minute. Mm, just 1 minute. Let's say this is a point, and I could have just drawn a line in such a way that it simply passes like this. That simply touches, and I
Yeah.
can simply join even this line in such a way that it touches like this. It touches both the
Mhm.
vertices. So as here, we can just draw it. I think question has said to copy on the grid. So we could have copied it on the grid actually. So I feel like it will be somewhere here, not there. This this red
Okay.
one. Uh, so this red one position, I think if we have to give the coordinates of the point, we don't know. We don't have any x or y axis right now. So I think we just
Yeah.
have to mark on that grid. We don't really have to give any coordinate for that. Or the better way was we could have just copied the diagram somewhere here. And we don't need any coordinate axis this time. We just have to show where it may lie. So this is the one of the figure. And the other figure we had was like this. Oh, sorry, it wasn't like this. It was like this. Yeah.
Hmm.
So now in the same manner, you just have to show. You have to show 1 minute. Let me just decrease its thickness and even this. Okay. So in such like we just draw the line in such a way that simply pass through both the vertices of both the diagrams like this.
Okay.
Yeah. Even this could have been drawn like that. And one more. This. So yeah. So I think this point.
Okay.
Let me just show you in the blue color. So the blue point simply shows that is the center of dilation. It must have come over here, but due to some arrow, it just has come slightly uh, left. But it's okay. You could have considered it somewhere here, right here. So that's the center of dilation for the question.
Okay.
Yeah. In the same manner for each of them, let's see the second part. In the second part, if we just copy the diagram, we can copy it anywhere on the grid. So it's 2 units is the height as well as 2 units is its base like this. This is the one of the image, one of the object, and the dilated image is at um, it's just upper vertex is same. It's at 1, 2, 3, fourth. 1, 2, 3, 4. Okay, it goes like this, and even it's touching somewhere here. Let me just count. It's one, two, three, four. One, two. Yeah, it's okay. So that's the actual
Okay.
diagram given to us in the B part. Now, in order to
Mhm.
get the center of enlargement, first of all, you just notice it's two. So it's one, two, three, four, five, six. So three is
Oh,
the
it's
scale
three.
factor. Yeah, scale factor is three. Now, in order to get your, we just simply mm, join the lines like this, and you can extend it somewhere here. Now, the other
Mhm.
line we can extend right here, and the third one we can just join right from the. Oh, sorry, this is our. Yeah. So you see, wherever they intersect each other, that's your
Yeah.
center of dilation, center of enlargement. So this blue point is your
Okay.
center of enlargement. Okay, Anu, so I think
Okay.
that's fine.
Yeah.
We can talk about next question. Question number two says describe fully the single transformation that maps triangle P onto triangle Q and the other. Okay, this time we also have been given some coordinate axis. So accordingly, we have to consider. Let's say this is my y-axis and this is the x-axis. So okay, let me write. This is y, this is x, and the figure given to us is. Let me just draw the figure also. It's right from here. Okay, and the image is 1 unit apart. It's one, two, three. So scale factor seems to be three. We can even just notice later, but first it looks like the scale factor is three. And one, two, three, four, five, six, seven. Yeah, it's three in fact. Two, three, four, five, six, seven, eight, nine. Now, in order to get the center of dilation, it should describe fully the single transformation. So it's just the enlargement, or you can say dilation. And for that, you need to just get the center of dilation. So for getting the center of dilation, you start joining the sides like this. This is the one vertex that you
Mhm.
join, and the other vertices you can join right from there, like this. And obviously, the third one is on the same line itself. I could have used some thicker lines. 1 minute. Yeah, that was the first one, and then the green one, the black one is the third one. So you see, all of the lines simply join at the origin. So origin is your
Yeah.
center of enlargement, and scale factor is 3. You can still consider the distance or the side's length. It's thrice. So
Okay.
scale factor is 3 with respect to origin.
Okay.
Yeah. Okay. Simple. You may tell if you have any doubt in this.
No.
Okay, after that, which question you would like to ask?
Hmm. I think I'll be fine with this one.
Okay, all the questions are fine up to fifth and sixth.
Yep.
Okay, so we'll just.
Oh yeah, I just have one question.
Yeah.
So if it were to ask like describe or tell what it is,
Mhm.
do we just say like if it's an enlargement or a reflection, do we just say that?
Yeah, we have to
Or do we
say.
have to add more details?
Yeah, we have to say like if it looks. See, there are two. Again, you just have. If in the exams, if it asks, it might ask anything. So the first thing you have to notice, it's a transformation, right? Then
Yeah.
you notice one other. Second thing that you must think, whether it's a kind of congruent figures or it's non-congruent. Whether it's congruent or
Oh,
it's changed. If it's congruent, There could have been a rotation, or it could have been a translation. Translation, let me correct. It can be a translation, or it can be
Okay.
a reflection, right? Let's see.
Okay.
But if the size gets changed, so either it can be enlargement or it can be a diminished. So it's just dilation.
Are
So
we supposed to mention if it's congruent or change or
you can
not?
simply observe the diagram, right? If you notice the
Yeah.
diagrams are congruent, both the object as well as image are congruent, then you would
Mm.
think either about rotation, translation, or reflection. The answer will be just from these 3 points. But if the size
Okay.
gets changed, then you would say that that's an enlargement or its a size is being decreased. And then you say it's a dilation, and then you have to give the rules like that. You just have to get the lines, you get the center of dilation, you compare the sides, then you get the scale factor.
Okay.
Yeah. Okay. All right, Anu. So after that, we have the next. I
It's
think
another
it's
chapter.
a chapter got ended, and we have the summary,
Yeah.
and we have some review questions as well. So if you want, you can even look at the review questions. If you find any question
Hmm.
difficult at once, just look at the third question. In the third one as well as in the fourth one,
Written
it seems that
or assessment.
oh, I'm just talking about review.
Okay.
Yeah, in review we see the question number third and the fourth one. It looks like the
Yeah.
figures are congruent, right? Only
Hmm.
their
Yeah.
orientation got changed. Their position and orientation got changed. So these in the third and fourth question there is no dilation. It's just either rotation, reflection, or translation. But in the
All
fifth
right.
question, you see the diagram D and the
Hmm.
diagram A, they got their sizes are different, right? So it
Yeah.
must have been dilation. So that's the difference.
Okay.
That's how you
Okay.
can analyze that. So what would you like? Would you like to have review questions or assessment questions?
I'll do review questions
Review.
because then I'll do
Mhm.
assessment later on my own.
Okay, okay. So let's begin with the first one. It's talking about the bearings, right? So
Yeah.
if you remember what I told you about the bearings are always considered whatever point is given to us as a reference point after the preposition from, just like bearing of point A from B. So the point which is after the preposition from, that has to be the reference point, and we have to draw a north line on that reference point, and then we move in the clockwise direction in order to measure the angle, and that remains the bearing.
Okay.
So in the given question, let me first draw the diagram, how the diagram they have drawn. This is our point A, and then we just draw a north line. This is my north line, and oh, they also have given some scale, so it's better to draw it on the grids. Yeah, this is our point A, and it says the diagram is drawn to a scale of where 1 centimeter equals 5 kilometer. What's the bearing of B from A? But they haven't. I think we have to use our protector on this diagram. We need to use our protector, right?
Yeah.
Unless we use our protector, we cannot get uh, we can't get our that measure of bearings. So we can guess it. Just 1 minute. Say it's the north line. This is the point A, and this is the point B. So it seems to be an acute angle, right?
Yeah.
It's a kind of acute angle, so it might be around 60 degree. Let's say this is the angle 60 degree. We have to move in the clockwise direction, remember. So while moving in
Yeah.
the clockwise direction, it seems to be 60 degree. So if I'm asked to get the bearing of B, let me write bearings Of B from A. If I write 60°, am I correct?
Isn't it A to B for 60 degrees?
No, it's okay. It's from B from A, right? A is the reference point. Whichever
Yeah.
letter is after the preposition from, that has to be a reference. So yeah, we have the reference point
Yeah.
and we have drawn it. So it seems all correct. Like it seems to have
Yeah.
everything is okay, I think. But there is still
Hmm?
an error. Its minute error is there. That is, the bearings are represented always in three figures, right?
Yeah.
Yeah, but I haven't used the third figure, so you have to write 0 before 60. So
Okay.
that was a mistake. So this is the exact answer we have to write. It's suppose 0, 60°. Okay. Now if it asks what's the bearing of A from B? Now how would you say? How would you do that?
So you do 360 times minus 60,
Yeah,
which is 300,
good.
and
That's
then you
how.
do
Yeah.
that minus 180, which is 120.
Yes, Anu, that's fine. Basically, you still have to move in the clockwise direction, right? So you
Yeah.
need this angle. This angle can be obtained because you know this angle is basically this angle is 120° this time. You don't minus 60. See, this angle will be 120°, right?
Yeah.
So the other part at the opposite end, it will be 360 negative 120. So
360 negative.
yeah, because it's 120, right?
So
These were lead angles,
2.
co-interior angles,
Okay.
right? And here we
Yeah.
get 240°. So 240° is the bearing of B. I just write bearing of A from the point B is 240°. Any doubt in this?
No.
Yeah, how did we get 120°? Because we know the concept of co-interior angle between two parallels. If we have two
Yeah.
parallels like this, there is a transversal, so the angles formed at one side are said to be corresponding interior angles, right? And their
Yeah.
sum is 180°. So if one of them is 60, other is 120. And then we just have got its opposite reflex angle, which is 240°. Then it says what's the length of AB in real life. So you might get, see, they have said that 1 centimeter is equal to 5 kilometers. That's what they said. So if 1
Yeah.
centimeter is equal 5 kilometers, then you may just measure it using a ruler. Say it's 1, 2, 3, 4, 5, 6, 7, 8. Suppose it's 8 centimeter or 7 centimeter. So therefore you would say 7 cent or even it may be in fractions, it might be 7.2 centimeter. So therefore 7.2 is just 5 times 7.2. So you would get 0. It's 35, 36 kilometers. Okay.
Okay.
Yeah. Tell if you have any doubt in bearing questions.
No.
Okay. You can still troll assessment exercise and then too you can ask if you have any doubt in them. Let's continue with the
Okay.
second question. Area of the given shapes. I think it's very easy. You can
Yeah.
get quite easily. Do you remember the formula for area of a trapezium?
Is it height times base times half?
Mm, no, Anu. Trapezium is what? Trapezium is something where we have two parallel
Is it
sides, right?
then
Mm-hmm. There are two parallels.
height times base
Mm-hmm.
times
Let me
like
tell
you
you.
have times the both parallel sides and the height?
Mm, Let me tell you. See, if we have this is the side A, its length is A, the length of the other parallel is B, and we may have a kind of height, which is the distance between the parallels. Say this is H. So if you remember, I told you a formula for area of a trapezium. It's half times sum of these parallel sides times height.
Oh, okay.
Yeah, that's the formula for area of a trapezium. So now can you calculate 2D, question number 2 in the D part?
Okay.
Yeah.
Just a sec. 2D, so 7 plus 2 times 11. So, 8, 9. Would it be 99? Hello?
Yes, Anu. Hello?
Hello?
Yes, Anu, can you hear me?
Um,
Hello, Anu, am I audible?
yeah.
Hello?
Hello?
Yes, Anu, can you hear me?
Yeah.
What happened? Wasn't I audible?
No, your voice was just breaking and then it suddenly stopped. So,
Okay, is
kind
it
of,
okay right now? Is it okay right now?
yeah.
Okay,
Yeah.
so yeah, did you solve? Did you get the answer?
Yeah, so is it 49.5?
Yeah, that's correct. Good. Very nice. What about the C part? It's a triangle. It's just a triangle, right? So
Yeah.
what's the formula for area of a triangle? Do you know?
Hmm. Do you times the height with the base?
Can you repeat?
Do you times the height with the base?
It's half times base times height. That's the formula, right?
Okay.
So there are different triangles are possible. It can be an kind of this acute angle triangle. It can be a right angle triangle. Even it can be a kind of obtuse angle triangle like that. So we can have
Okay.
base and heights wherever we want or wherever it's given, we have to consider it. Let's say in this figure, the first one, this may be considered as the height, right?
Okay.
In the second figure, that one of the side itself is the height, other is the base. See, this
Hmm.
red one is the height, and the blue one is the base. In the first one, even in the second one, this blue one is the base. It has to be a right angle, in fact. Unless it's a right angle, we can't consider it as the height. So in this right triangle, one of the leg itself is the height. But now if
Okay.
you want to draw a height, say this is the base, how do we consider the height in this triangle? Even if you want
Would
to
you do
draw a
it?
perpendicular, we won't be able to draw a 90-degree anyhow within the triangle.
So
Mhm.
would it be like outside the triangles over
Yeah,
here?
yeah, correct. We just need to draw it outside the triangle, and we can even produce this bottom side. Not, it won't be considered actually, but it's just produced in order to just get the intersection and in order to get the height of the triangle. We just produced it.
Okay.
Yeah. So yeah, this is also the height. So that's why that's how they have given in the 2C question. I'm telling you this
Okay.
thing just because of question number 2C. They have given the height outside the triangle. The formula is still the same. Its area of the triangle is half times base times height. So the base is what? It's 1.5 and the height is 3
Mhm.
millimeters. So you would get even again it's 1.5. So it's 2.25. Shall we
Yeah.
leave the answer like that only?
Like, do you just
Or
add millimeters to it?
yeah, you have to write millimeters. So is it just millimeter?
Yeah.
No, it's millimeter is squared. It's an area,
Oh,
right?
okay.
So area is
Yeah.
always given in square units. Millimeter is square, centimeter is square, meter is square, like that.
Okay.
Yeah. Okay. All right, Anu. So that's it in this. I think rest of the
Okay.
questions. What about the area of a parallelogram?
Mm,
Hmm.
Do you, like, for the one given, would you do 13?
What formula you will
Would
use first
you,
of all? Tell me.
would you add both the sides and then by
No,
height?
area of a parallelogram is very simple. It's just base times height. It's base multiplied by height.
Okay.
You can go through the previous sessions that we did, so you would understand like the same thing that we already have done, different formulas. Or if you want, I can right now write each and every formula. Let me start from the rectangle. Rectangle has two dimensions, length and width, right?
Yeah.
So let me write area of the rectangle. You can just memorize all the formula that I'm telling. It's length times width. Then for the parallelogram, parallelogram is something which has all the, like opposite sides equal and parallel, but the angles are not essentially right angles. So it's little different than rectangle. It's a kind of parallelogram, right?
Yeah.
So in this parallelogram, we can still have its height. Height can be drawn from either of the vertex. It's at right angle. This is the height, and the base is the bottom side. This is height, and this is the base. So area of a parallelogram. Let me write area of parallelogram. We write it as parallelogram, but we just read it as parallelogram. And the formula is very simple. It's base times height.
Okay.
Yeah. Now for the triangle, we just discussed that it can have a height where anywhere, wherever we want, according to the given question. Even it's not like that. It could have been even in this way. Don't think that height is always drawn at the bottom side. If it's drawn like that, the side which is adjacent, which is just corresponding to this height, is the base now. Now this red one will be considered as the base.
Oh,
This
okay.
time, yeah, this is the base. And then this will be the height. It's at right angle. So even this is also here also we can apply the formula. Area of triangle is given by a formula half times base times height. We've done rectangle, parallelogram, triangle, then trapezoid or trapezium. Trapezium is what? It has basically two sides parallel, whereas two other sides are non-parallel.
Okay.
So, Anu, I just have told you the formula.
Yeah.
Can you tell me what's the formula for area of a trapezium?
So it's half times, like, you have to add both the parallel sides and times it with the height.
Correct, very good, quite correct. We have to consider the same formula that you told. Let's consider this is the h, the height of between the two parallel, or the distance between the two parallel sides. So area of trapezium is equal to half times sum of parallel sides times height. So one of the parallel side was A, other was B, and the height between, that is distance between them, is h.
Okay.
That's it in this area of a trapezium. Then we had one more object. I think it's not there in the questions, but I think we discussed that. It's a rhombus, right? Rhombus is something which is just like a square,
Okay.
and it's okay. I also forgot to tell you the formula for area of a square. Do you know
For
what's the
square,
formula for area of a square?
it's just
Yeah.
height times space, right? So,
Mm, Let me tell you. A square look like this.
so you can just, because all the
So
sides are equal, you can just take one side
yeah,
and square it.
exactly. You just have both length and width. They both are the same.
Yeah.
So area of the square is just side square. That's simple.
Yeah.
Okay. But for our rhombus, though the sides are still equal, but we have to use a different formula in which we have to assume say this is our D1. That means the first diagonal, and this is the D2, the second diagonal. We have our D1 and D2. So we have to use the formula area of the rhombus is half times d1 times d2. d1 and d2 are just the diagonals.
Okay.
So you can still use that formula as well.
Okay.
Okay. Yeah, so that are the formula for our 2D objects, two-dimensional objects. So there is no problem in them. And after that, we have questions based on transformation, Anu. So you may try them, and wherever you have a doubt, you can also try the exercise assessment exercise.
All right.
We have lots of questions in them. You may try them wherever you feel a doubt. Feel free to ask me
Okay.
as many as times you want. And anything else that you want to ask in today's session?
Hmm. No, not really.
All right, Anu. So our session time is about to over.
Okay.
And all right, do you go to
Oh,
school? Like,
well, my school's starting in 8th of January.
they're starting on 8th.
Yeah.
Okay, so just enjoy your holidays
Yeah.
in the new year. The new year has just started.
Yeah.
So, all right.
Okay.
Okay, Anu. So
Want
we'll
to tell
meet
you
next.
that
Uh,
I'm not sure, but I might have a test when I come back. So
okay.
I I think like after the 8th, we might have to do a revision session, but like the revision session that the topics we've already done.
Mhm. Yeah, sure. No problem. We
Okay.
can do as per the need. Okay. All right, Anu. So we'll say bye. Bye
Okay.
bye. Take
Bye.
care. Bye.